Feel about this? Well, he wasn't satisfied with his theory either. He was unhappy because the theory only applied to observers moving in a straight line at a constant speed. The theory did not apply if gravity was present or if the observer was accelerating. Einstein was known, however, to have a very vivid imagination, and one day, as legend has it, while observing a window washer on a ladder near his patent office, he had one of his famous thought experiments that would go on to change the course of scientific history. He imagined what would happen if the worker were to fall, but he didn't think of it the same way you and I would think of it. What was his thought experiment, and how did it lead to perhaps the greatest single scientific theory of the past 100 filmmakers and producers who bring you premium quality documentary content? Featured subjects include history, nature, and of course science and space. You can watch it on any of your devices at any time and in 4K. I'm delighted that Magellan TV has a special offer for our Match years. If you use the link in the description, you'll get a free 1-month trial. I highly recommend Magellan TV, but be sure to use the link in the description. While watching the window washer on a ladder, Einstein thought about what would happen if the window washer fell. For most people, imagining this would just conjure up disturbing images of the poor guy landing on the ground below, and the story would not have a happy ending. Einstein thought about it differently. He put himself in the window washer's perspective and imagined not what would happen when he met the ground, but what he would experience as he was falling. What he realized was that if he was falling, gravity would be the only force acting on him. He would be accelerating towards the ground, but since the ground would not be pushing up against his body, he would feel no weight. With no weight resistance, he would be in free fall, and this would be no different than being weightless in space. In a way, gravity and acceleration were different ways to describe the same thing. This is where Einstein had a huge insight. The way to connect gravity with the theory of relativity was to the idea of acceleration, since the two are equivalent. Einstein imagined being in a room with no windows, and if the room had a bathroom scale handy, what would happen if you stepped on the scale? Well, if anywhere stationary on Earth, you would weigh 80 kilograms, or whatever your weight is. Now he imagined being in the same room in space. Now what if the room was on a spaceship that was accelerating in an upward direction at 9.8 meters per second, which happens to be the exact same as the gravitational acceleration on Earth? What would happen when he stepped on the scale then? Well, the scale would read 80 kilograms, just like it did on Earth. The acceleration on the spaceship would appear to him inside the room as being indistinguishable from being stationary on Earth. If he didn't know he was on a spaceship, he could just as well presume he was on Earth. There would be no way to tell the difference, or would there? Einstein thought about this and asked himself if there was a way to tell the difference. He imagined what would happen if he took a flashlight or a laser beam and pointed it from one side of the room to the other as the spaceship was accelerating upwards. If he had a sensitive measuring instrument, he could measure the height of the light on the other side of the room. He realized that the height he would find on the other side of the room would be slightly lower than the source of the light. Why? Because the floor of the room would be rushing upwards at ever faster speeds as the light was propagating across the room. Since the room